Thank you for click on this video. I sajal.sasmal welcome you to complete lecture series of solar photovoltaics. Please click on description for playlist of complete solar cell tutorial. Let's start. Arbitrary orientation and tilt. For a module at an arbitrary tilt and orientation, the equation becomes a little more complicated. Alpha is the sun elevation angle and theta is the sun azimuth angle. Beta is the module tilt angle. A module lying flat on the ground has beta equals 0 degrees and a vertical module has a beta equals 90 degrees. Psi is the azimuth angle that the module faces. The vast majority of modules are aligned to face towards the equator. A module in the southern hemisphere will be facing north with psi equals 0 degrees, and a module in the northern hemisphere will typically face directly south with psi equals 180 degrees. S module and S incident are respectively the light intensities on the module and of the incoming light in W per square meter, the S incident being a direct-only component. A module that directly faces the sun so that the incoming rays are perpendicular to the module surface has the module tilt equal to the sun's zenith angle, 90 alpha equals beta, and the module azimuth angle equal to the sun's azimuth angle, psi equals theta. The following calculations combine the calculation of sun's position with the air mass formula and then calculates the intensity of light incident on a module with arbitrary tilt and orientation. Using vectors to calculate solar direction as the number of tilts and orientations become more complicated, it is often easier to convert the solar directions of azimuth and elevation to vectors. An example is where there is a tilted module on a building that is also at an arbitrary tilt and orientation. The simplicity of using vector comes from the fact that the reduction in intensity of light on a tilted surface is simply the dot product between the incident ray and the normal to the module. Light striking a surface at an angle is spread out over a larger area. The reduction in intensity is the dot product of the unit vectors s and n, where s module and s incident are as defined before, and s is the unit vector point towards the sun and n is the unit vector normal to the surface of the module. Gamma is the angle between the two vectors. Thank you for watching the video. Please like and share this video. I will be so happy if you subscribe my YouTube channel. Click on description for playlist of complete solar cell tutorial.